Hi, I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. In the last two videos we created this basic Luma mask shader and remapped the base sprite's UVs to the mask UVs, so any shaped base sprite and mask on any texture page work together. In this video we'll improve our Luma mask dissolve shader by adding a rim with two colors. This will be quite easy and fast since we wrote most of the code in the last two videos and there's nothing too complicated to explain here. That said, if you haven't watched the first two Luma mask videos, you might struggle following this one. But as always, a short disclaimer first.
This tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths, so if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you.
So as usual, let me first talk about how we are going to create this two-colored rim. Here we can see two different masks. One boring simple gradient because it's easy to understand what's happening with a gradient, and some blurry light dots on a black background, which was actually used in the preview from a few seconds ago. Beneath those are the base sprites we're going to mask. And this is going to be the end result of today's video. With the animation time at 0, the base sprite would be invisible, and animation time at 1 would mean the base sprite is fully visible. This snapshot was taken at a time value of about 0.5, so halfway into the animation. We'll have to build the effect in several steps represented by those colored lines. So let's get a quick overview what those steps are first. If the fragment is outside the orange line, alpha is 0. Else alpha is the base sprite's alpha. If the fragment is inside the orange line, its color is the outer rim color, in this example a yellowish white. Unless it's inside the green line, then the color is the inner rim color, a dark brown. But if it's inside the blue line even, then the color will be the base sprite's fragment color. But we're not going to use if statements. All of these lines will instead be determined by a step function. The result of the step function, always a 0 or a 1, will be used to toggle the alpha and to mix the two rim colors and the base sprite's color. So let's have a closer look at how we're going to code this. The first part will be the orange line, toggling the alpha. In our Luma mask code from the first video, maskval is the value of the fragment on the mask texture, so something from black to white or 0 to 1. And timext is the time of the fade-in animation extended by the size of the effect. So with a size of 0.3, time would go from 0 to 1, but timext would go from 0 to 1.3. Now if timext is larger than the value of the mask's current fragment, then the alpha factor is 1. And if time extended is smaller than the mask value, the alpha factor is 0. In our example, timext is at 0.65 out of 1.3, so halfway through the animation. And in the orange area are the mask's fragments with a value of 0.65 or less. Every fragment with a mask value of 0.65 or less is getting an alpha factor of 1. And every fragment with a value more than 0.65 is getting an alpha factor of 0. Or in other words, the rather bright fragments on the mask are still invisible and the rest is visible already. If you don't understand this line of code, I strongly recommend to watch the first video on Luma masks. It's the core of our Luma mask shader and explained there in detail. In the end, we'll set the output colors alpha to the base sprite's alpha multiplied by this alpha factor, which means outside the orange area is always alpha 0 and inside it's always the base sprite's alpha. The next step is setting the inner and outer rim color. The uniform rim size will replace the uniform tolerance from earlier videos, but will be used in the same way really. So it's not a size in pixels or UVs, it's describing a bandwidth of luminance values. All fragments within that bandwidth are part of the rim. I'll also define 3 macros, but you can use uniforms or constants if you want to. 2 of those macros are the 2 RGB colors of the rim, and the third macro will set how much in % of the rim size the outer color will get. So 0.5 would mean the outer and inner rim are both equally large. 0.25, like in this example, means the outer color will get much less space than the inner color. Now we're going to mix the inner and the outer color. To set whether a fragment is within the green line or outside, we'll use a step function again. If timext is smaller than the masked fragment's value plus the outer % of the rim size, then weight will be 0, and this means the mix function will set the output fragment's color to the outer rim color. But if timex is larger than the mask fragment value plus the outer percent, then the weight will be 1, and thus the mix function will set the output fragments color to the inner color. So after this step, everything outside the orange line is the outer rim color but invisible. Everything between the orange line and the green line is the outer rim color and visible. And everything in the green area is the inner rim color. The base sprites color is still completely ignored, which takes us to the final step, getting the base sprites fragment color in. This step follows the same logic really. If timex is still smaller than the mask fragments value plus rim size, the weight will be 0 and the mix function will leave the color unchanged. But if timex already is larger than the mask fragments value plus the rim size, then weight will be 1 and thus the mix will set the output color to the base fragments color. So everything outside the blue line remains as it was before this step, but every fragment inside the blue line now receives the base sprites color. And that's pretty much it. No magic involved, it's as simple as that. So let's switch to GameMaker Studio and code this. We'll need a base sprite and I'll be using this square mockup menu sprite. Then we'll need a mask sprite. I'm using the one we've already seen in the introduction of this video. And if you are using a remapping technique as shown in the last 2 videos, the base sprite and the mask can be on any mixed texture page. But if not, you need them to be on a separate texture page each. I'm going to base this object and shader on the version with remapped UVs from the last video, not on the vertex buffer version and not on the basic version without remapping from the first video. The steps shown before should be the same in all versions though, and easy to adapt if you want to. So let's duplicate object Luma mask mixed text remapped UVs and name it object Luma mask color rim mixed text remapped UVs and place the object on the main layer of our test room. And then we can also duplicate shader Luma mask mixed text remap UVs and name it shader Luma mask color rim mixed text remapped UVs. Inside the create event, I'll once more set the info text for this module. Then as shader we need to set the new shader which is duplicated. As sprite I'm setting the square mockup menu sprite, and as mask I'm setting the blobs mask. And in the uniforms part I'm changing tolerance to rim size because that just makes more sense to me in this effect. The rest of the create event can stay the same. We still need the mask texture and the mask transform to remap the UVs. We still need time and inverse uniforms, and we can leave the GUI settings as well. The step event remains unchanged as well. And in draw event all we need to do is replace tolerance with rim size again. And that's all for the object, so let's open the shader. The vertex shader will stay the same as well. All we did here is remap the UVs and pass them to the fragment shader with the varying vector mask chord. So let's close it. The main changes are in the fragment shader. First let's replace tolerance with rim size as well. Now we can add the macros as showed in the introduction. As mentioned before, you can use constants or uniforms if you want to. So we need the inner color, outer color, and outer percent. Mind that if you're using macros, you should never add a semicolon. And inside the main function we won't need that one line where we smooth stepped the mask value and can completely remove that. And now we can get our new code in here. First the step where we toggle the alpha factor. Float alpha is step of mask value and timexed. Then the outer versus inner rim color. Float weight is step of mask val plus outer percent times rim size and timexed. And vec3 rim color is mix the outer color with the inner color by the mix amount of weight. Next, the inner rim color versus the base color. Weight is step of mask val plus rim size and timexed. And rim color is a mix of rim color and base color.rgb by the mix amount of weight. And finally, when setting the output color, we need to replace base call with rim call because that's the result of those two mix functions, and mask val with alpha since that's our alpha factor now. And that's it already, so let's run this. Now just a very quick improvement. Depending on the mask sprite's pattern and quality, all these step functions could lead to ugly hard edges between the colors. I'm going to offer an alternative by replacing step with smooth step. So back in the fragment shader, I'm adding a new macro. I'll call it AA for anti-aliasing, which is not really correct but kinda descriptive, and set it to a really low value like 0.01. And now I'll just replace all step functions with a smooth step. Value 1 stays the same, value 2 is always value 1 plus AA, and the edge stays time xed. Like this, we'll be able to soften those edges just a little bit. And so let's run this again and check what it looks like. Now I can't tell if you see this in the video, and to be honest, this mask wasn't really prone to jagged edges anyways, but in my opinion this still is an improvement. And that's it for this video. In the next video we'll use a ramp texture to create more flexible transitions and create this fiery dissolve shader with it. Until next time.